Hey guys, I'm starting a series on writing Solana programs with Steel. So Steel is a framework for writing Solana smart contracts, and it's pretty similar to Anchor, which is also a framework, but it's more lightweight, and you get to understand things that are happening behind the scenes that Anchor don't doesn't like really show you. So Anchor is still under development, so as it says here, things might change. So I want to do a series where I implement basic things in Steel. So this video is going to be like an introduction to all that. At the end of it, we'll pretty much write the Hello World program, go over like the structure of a Steel program, and explain mostly what we have right now. So to get Steel on your machine, you need to have Rust. I'm not going to go over that. I'm going to drop a link in the description that like directs you on how you can install Rust. So when you have Rust installed and you have Cargo installed, you have to like all you need to do is run this command to get Steel on your um, machine. So I already have Steel on my machine. So let me just get to it. So to make sure you have Steel installed, you just need to like run Steel and all this should appear. So to create a new Steel project, you just need to do Steel new. Uh, I'll call our project Hello Steel and Hello Steel Z. Yeah. So Steel projects. This is currently like the structure of Steel projects. We have like two folders: API and program. So program is mostly what you're focused to it. It's where you have the business logic for your instructions. And yeah, usually have your instructions, have their own file and their business logic. That's majorly what the program um, folder is for. Then API is where you have things like your state, your const, your error, instruction. So instruction has your instruction data, basically what you send when you're like for an instruction when you're running an instruction. And SDK is where we just build up our instructions. So we pass in the program ID, which is like the ID for the program you're writing, the accounts you're going to use in this instruction, and data you're sending to it. So yeah. Also, still still projects use Rust. So you can use Rust for testing. You can also use Rust for testing and code programs, but it's not as like straightforward as you would use Steel with still to do the same thing. So if you notice, this straight out of the box, we already have a program when we do Steel new, so it has this like template already down for you, and I'm just going to go through it to like explain more things about Steel projects. So the program we have is like a basic counter program. In Initialize, we create the anchor. We create the counter account that's going to keep track of the counter, and it has a value field, and we assign that to 0. And over in add, we just like add the value by whatever amount we pass. So let me go through the lines of the initialize instruction. So first things first, we need to load in the accounts. So this is pretty similar to what in Anchor, your account struct. So jog your memory, your account struct will probably be something like this. Initial, forgot how to spell initialize. Well, so something like initialize, and okay, in the context of something like this where we have signer. I'm bringing it down so you guys can see and so I can also remember. So it'd be something like signer info. Yeah, it'll probably have an is it accounts news? It'll probably have accounts over it at the top too, and then we'd have our PDs and stuff. So it's pretty similar to the account struct in Anchor. So we just we load our accounts over here, and One thing you might not be aware of is that, for example, in your, okay, let's say, in Anchor, if you'd have something like, let's say, signer, then let's say signer like this actually checks, it does the check for you that confirms that this account is actually a signer. So that's pretty much the same thing we're doing over here. This method is just going to check if this account is a signer as we intend for it to be. And so that's something that's really important. On Solana, a lot of things are accounts. We work with accounts a lot, and it's like critical points where vulnerabilities can come out from. So we have to be sure that we're getting the right accounts passed into instructions. So in Anchor, you'd probably have that done for you with some like abstraction and all, but with still you have to do some of these things directly. But luckily, we have some methods that make it like a bit easier. So that's basically what this is signer method is for. It just checks if this account is a signer. So counter info is going to be like a PDA. So we're creating it in this instruction. So the first method is empty checks if this account is empty because we're just creating it. The second one checks if it's mutable, is writable, and the third one just checks if it has this set of seeds. So for system program, we basically need system program because we're creating an account. So for system program, we use the is program method, which checks if this account is a program, and the param just tells us what program in particular it should be. So after we're done with the checks, we go into our business logic. So over here, what this does is just create an account as the method name says. So this is a still method that just creates an account. So I did that wrong. So I want to like place it side by side so I could like really explain the method. So basically this method, the first param is targets account. So in this scenario, counter info is the target account because that's what we want to create. Then the next one is the system program. That's what we have here. Then the payer. That's why we have signer info here. Then the owner, since this is going to be a PDA, we're going to have it be the address of this program and the seeds, which is this. So counter is basically the seeds over here, the binary of counter. So that's it. So we get an instance of counter over here and we just set the value to 0. So that's basically what we're doing in Initialize. So let's look at what's happening in add. So in add, notice in add we're getting the args. Over in Initialize, we didn't need to do that, and that's also the reason why over here we had this param have a underscore in front of it. This just tells us that we're not using this parameter. But over in add, since we have some data we need to send to this instruction, just like basically a parameter. Okay, so that's why we have data without the underscore in front of it, and this is how we get the data out. So this first point 5 to 7 is just like getting the params we're going to need, and the only param we need we're sending to this instruction is just amount. So just like we did before, we load the accounts and we place some checks on them. On signer, we just check if signer is a signer. And over here we check if the counter the counter account that is passed is owned by the program. And over here we just check that the value it has is less than 100. So then over here we just increment the value by the amount we pass. So pretty straightforward. That's what we have in add and initialize. So let's also go over API so we could like see how they define the state and all that. So since we have a counter account, this is where we define the account, define the type of it, the counter type, and over here we just like declare it as an account. So this is how still knows that this is supposed to be an account. And over in mod, so over here is like where you'd add all the accounts you have for this program. So since we really only have counter over here, that's why it's only counter. So if you add another one, it would be like so let's say account 2 would be equal to like, let's say 1 and so forth. Let's say we add another, let's say another account, and that would be equals to like 2. So get it like that. So this function here just pretty much helps us to find the address of a PDA. So we use the seeds to just the seeds and the program ID. But I'm thinking if we had like multiple accounts in this multiple PDAs in this program, I think it would have been easier to just call it maybe find PDA, then have seed as a parameter, because it wouldn't be, I'd imagine like creating the same function like 3 times would be pretty annoying. But it's pretty nice to have it here because it shows you like, oh, you could do this, and it could make things easier for you. And we're going to actually use this a lot as we move forward. So over in const, we have like seeds and all that. In error, you wouldn't guess it, but we actually have errors here. So in instruction, we have like the instruction data. Think of the instruction data basically as the parameter, what we're supposed to send for this instruction. So for initialize, it's empty because, oh, we're not sending any data, or we're not using like any parameters for initialize. But in add, we use amount because, okay, we're sending like we're using an amount argument for the add instruction. So over here we just like define the instruction, I guess, or declare the instruction, I guess. Yeah. So leave.rs just brings everything out. Then over here in SDK, so in SDK we pretty much build the instructions. So for initialize, we just like, yeah, we add the program ID, the accounts we're supposed to use in this instruction, and the data. So because initialize doesn't take any like data, that's why this is empty. So it's pretty similar to like what we have here. It's empty. So if you SDK, if you try to look into it, it will just take you to instructions. And over here in add, so pretty much have the same thing, program, the accounts we need, and data is not empty this time, like it has amounts because this instruction takes an argument. So yeah, that's pretty much what's happening over in API. So in API pretty much define states, const, things you would use in your program, and in program you actually write out your program logic. And there's also a folder, I think I've not explained, test. So test is inside the program folder, and it's pretty much just your tests. Test in Rust. Who doesn't love test in Rust? Like I do. So yeah, the test aren't that complicated, but yeah, let's go over them. Let's first try to like build our project. Typically, how you build your still projects, I would just with still build. So under the hood, all this does is just run cargo SPF. So in case you didn't hear me correctly, it's like cargo build SPF. Like this is just what cargo still build is doing. So hopefully this doesn't take too long. Okay, yeah, so it's done. Let me split it. So I'd like to like explain the test logic. So this is the setup. So it uses program tests. So it just sets it up right over here. So you first run the setup over here, then at this point afterwards you can like call your instructions and all that. So initialize, for instance, now our initialize instruction, we get this from SDK. So it's from SDK that we can actually like get the instruction before we can use it. So oh lord, where's test? Yeah, so we get the instruction over here, basically construct the instruction over here. Then over here we sign the transaction with a pub key with the payer. So that's going to be like default payer we're using. Then over here we process the transaction. So this is going to return, it's supposed to like return a results type. So either can be the okay variant or the error variant. So if this is okay, it passes, but if it's not, it fails. That should be straightforward. Then over here we like test if initialized work properly. So over initialize we did a couple of things. Where is it? Yeah. In Initialize, we created an account, the counter account, and we also like set the value to 0. So we need to like test if that actually did happen. So we try to get the address of the counter, and this is where this what do you call it? This function I talked about earlier comes in, and the counter PDA, it helps us get the counter address, and it also helped us in SDK, but I just realized that I did not mention it there. Like, watch over here, we use it to like get the address of the counter PDA. And also something I forgot to mention over at this point, so these are the accounts. If you notice, we're creating like a account method new. This one is true while the others are false. That's because, okay, this is true because, okay, let's just look at the definition, the pub key and e-signer. So this is true, and it's telling us that, oh, this account is supposed to be a signer, and the other ones are false because they are not. So over in add, you see the same thing. This is true because it's supposed to be a signer. So back to our tests. So we get the counter address, account, get an instance of counter, and we check if the counter account is actually owned by the program. So asset equals, like, this is the ID of our program. We check if it's right. Then we check if it's the value is 0. So this is just a test for the initialize instruction we just ran. So next, we call the add instruction. So we just construct the instruction over here. Then over here we sign the transaction and we process it, and we just check that, oh, it all worked fine. Then we just, all we do right here is just like check if the value was incremented. Since we passed in 42 right over here, it's supposed to be like 42 because it was 0 before. So because all add does is just like add what we had before, which was 0 to like 42. So that's why it's 42 over here. No brainer. So let's run it. So we run it by just running still test. So this is going to take a while. Yeah, and our tests are done. And this is one of the things I like with still. I like the way it just logs out everything. I like the way it just logs out everything. It's pretty fine. So it shows that our tests work. So honestly, yeah, so we did not like pass in any logs, so that's why we don't see any custom logs. These are just like program logs over here. So yeah, that's done. So now that we have that done, let's go basically just like make an instruction that says hello. So I'm thinking about the best way to get that done. Well, we could just create the third instruction. Yeah, third instruction. Let's just call that hello.rs. I'm just going to like copy this, paste over here. We really do not need any accounts. Well, we can use signer. Maybe signer to like show that, oh, this particular person called it. Okay, let's just keep signer. So we're going to take off a good chunk of this. Remove system program and counter since we're not using them. What else? Okay, yeah, declare it in lead.rs. Mode hello. Yeah, so we're basically just adding an hello instruction. So process initialize. Oh yeah, so over here we need to rename this to hello. Yeah, We also need to import the message macro. So that should be in Solana program. Solana program. Yeah. Solana program. So over here we just do hello still. Should I say? Yeah, hello still world. Yeah, hello still world. Then like okay, message. Should be able to do called by. Oh yeah, sorry. So it'll be like called by. Shouldn't be able to do signer info.key. Yeah. So like hello still world and called by the public key of the signer. Yeah, so to make this work we need to do a couple more things over and leave the tires to like define it. So over here let's say hello and here just say hello. So this won't work because we do not have like hello in the hello still instructions. So that's over here. So we could just copy this, name it hello, name it hello here, and we should be good on this front. Why is it not? Why define the hello here? Sometimes it's hard to tell if errors are there or it's just taking Rust Analyzer a minute. Oh yeah, it's because I did not add API. Ah, so nice. Sometimes you think it's your computer, but it's just you. Yeah, so we have this. Where else should we have our error? Okay, we can remove this. Yeah, we also have to define it in SDK. So over in SDK, we just do. So we're going to So we're going to remove counter and system. This hello. Yeah, yeah, we should be good. We should be good. So head over to the test. We could even define it first. So would be like submit hello to x. So yeah, let's instruction equals hello, not that hello. Did I define it? Yeah. So pair dot pop key. Can pretty much take all this, paste it. I'm just trying to fast track things because we really do not need to spend this much time here. But I just want to like fulfill all righteousness and like have hello world. Yeah, so with this we should be able to like log cons hello world. So it's actually very possible to do this with less lines of code, but I'm just following like the file structure we have with steel and all that. And let's look for hello world still and look at it over here. It says hello world still, and where's our second log? We had 2 logs. Oh yeah, see, called by the pop key. Yeah, and that's it. We have a hello world program. Like, if I can learn video editing, I would probably like add a clapping sound effect, but I can't. I don't know any video editing right now. So yeah, that's it. We have our hello world program. So there are actually easier ways to do this. If you check Solana program examples, basics. Hello Solana still. So pretty much a still program. So this is how you do it in just one line. Well, I wanted to like explain the structure of how steel programs work, and that's why I like did all this so like I could explain all that. So yeah, this is our first video. I know it's not like the you could like go you could just like exit the video now, but yeah, it wasn't top notch, but yeah, it's a first time thing for me or second time thing. As we move on, I'll get better and all that. So leave a like, follow, share, and expect the rest of the series. Thank you guys. Bye.